Thank you, Chris. It's always an honor to be able to talk to the Vivint crowd, and I am happy to be here today to talk about the Internet of Things. I am part of Transact IQ now. I am the Chief Technology Officer there, but that is a name change. Some of you may have remembered us as Endpoint IoT. So while the Internet of Things is a core thing that's important to us, we're also expanding into blockchain, cloud migrations, some specific security solutions and things of that nature. But Internet of Things is still really front and center for us. And so today I'm going to be talking about how would we performance test the Internet of Things from the perspective of somebody, and I feel like probably many of you have the same background as me, where you've been doing performance testing or you've experienced performance testing in the enterprise space. So web, legacy apps, Citrix-based applications. So you're used to that kind of performance testing, and now you're hearing more and more about Internet of Things, and you're thinking, how do I apply the knowledge I already have to an Internet of Things platform? What's the same and what's different? And in the amount of time that I have to try to condense this down for you, I'm going to cover a couple of protocols called MQTT and CoAP, and we'll dive a little bit into the weeds about that. And I'm going to actually show you what it would look like using a tool that we're familiar with, which is LoadRunner, to do some of this testing, at least from the scripting perspective. And I'll share some of the things that we've learned at Transact IQ for best practices. One of the things that I put about me here is that I'm a SEAL, a software engineer across the life cycle. And what that really means is I think about performance throughout an entire life cycle, but I have a very limited scope, so a very wide range of interest in development, test, and production. But I'm not just a performance tester, which means I should be able to look at something that you're dealing with where you're struggling with performance, and I may be able to solve your problem without ever running a single test. And that's the kind of approach that you need to think about when you start thinking about Internet of Things, because it will require you to think outside the box. And we'll see this as we kind of dive into this. I would encourage you to use the button that expands your screen to full size, because some of these pictures I'm going to show you, you want to see the bigger picture. And as we go through the demo, you'll be able to read it a lot better. So let's just dive right into what an IoT architecture typically looks like. And from this screen that I'm showing now, this slide, look from the right to the left. On the right-hand side, we have the world as we know it. Could be inside, outside, and we're going to have these things that are inside the world: temperature gauges, pressure gauges, speed changes if you're inside a moving vehicle. So these sensors are going to be anywhere and everywhere, and they're going to react to certain changes, receive data, and transmit data. But they're not going to do it in the same way that a traditional website might take information from a form field entry and submit that to a traditional database. But on the left-hand side, we have the network itself, which could be Ethernet, could be Wi-Fi, could be something else, all the way back to the cloud. That could be your data center with traditional web servers, traditional databases, or it could be Amazon, Azure, or Google Compute platform. So the left-hand side is more of what the traditional enterprise testers are familiar with. Right-hand side is kind of what we're trying to figure out, what is that stuff, right? So that's kind of where we're going to go with this, and I'll try to make the transition. And this is a slide where you really definitely need to blow it up, because at the very bottom of this vector is the sensor itself that we were talking about. So this could be, say, a temperature reader that is outside of your house or your apartment. And when a temperature changes outside, it sends that change somewhere. Now, that could be, depending on the location, it could be a Wi-Fi router in your house. It could be sending something, let's say you're sending an Alexa call to Alexa for home automation. But how it gets to the back end or the cloud that we know about, that's really based upon the IoT platform that you're choosing. That sensor is going to transmit over some type of a wireless protocol but it may not be Wi-Fi. It may not be something that is even in the mobile space. Like it could be 3G, 4G, LTE. It could be through Verizon. There could be some kind of a connection like that to a cellular tower. But the wireless protocol could also be dependent upon power requirements. It could be dependent on length of distance between the sensor and wherever it needs to transmit that information. And that place that it's going to send it to is, we would call that a gateway. Those gateways can just receive the data and retransmit it back up to a backend server. They may have a smart gateway with some kind of programming logic that makes some level of business decisions. But when we talk about how it transmits that data, there's two types of thought processes around protocols. A physical protocol, so we're replacing Ethernet cables with a wireless technology. Why wouldn't we use Wi-Fi? Well, you could, but some of the wireless technologies are a little more power hungry than we would want. So we have to think of transmission rates and what those power requirements are. So when you see words like polling, where it has to keep checking a device, you have to start thinking about battery drain, because everything has to be powered, even those sensors. So if you're metering something like a smart meter, you don't want to have to send technicians out every 6 months or a year to replace a battery, because that's going to make the deployment very, very expensive. I think it's an average of $300 to $500 just to replace each individual battery. And you have thousands of sensors over a smart city, even millions. Battery life is very important. You want something that's going to last 5 to 7 years, typically, if you can. So we don't want the batteries to drain. So we have to think about that wireless transmission in terms of how long can the battery last and keep transmitting, but also the distance between it. Older versions of Bluetooth may be measured in feet. New versions of Bluetooth may be measured in yards. LoRaWAN, you may get miles for line of sight. So the distance traveled and how constrained the network are all have to do with that quote-unquote physical transport layer. But there's also that layer that comes after that, which is the data transport layer. So this is where, as a tester or an engineer, you really need to be familiar with how protocols like TCP/IP work and what sits on top of those protocols. So we would think of TCP/IP when we talk about TCP transport and the UDP, the datagrams, how TCP works and UDP works when it's talking back and forth to servers. And then what sits on top of that? Protocols like FTP, HTTP, things that we're used to. So we are going to have to consider replacements for HTTP because of the same constraints that we're dealing with these small sensors, small payloads, and things of that nature. As you get further up in this diagram, closer to the top is where you start getting it transmitted from these HTTP replacements into what we know, HTTP through a REST call, some type of API that eventually gets it up into a web server, into a traditional database server where it can provide graphs, metrics with traditional-based cloud deployed web applications. So I hope I didn't bring you too deep in there, but we have to spend some time in protocols when you're talking about IoT, because that's really the secret sauce that makes this stuff run. And this is just a slide showing you a little more than half a dozen of the protocols that we see most out in the market right now. MQTT and CoAP being probably the most popular. And it talks about here who the sponsors are, how it responds appropriately to highly constrained networks, what the security model is. So when we start talking about the transport mechanism, when we get down to the TCP/IP layer, we're concerned with, is it TCP-based, where we need acknowledgments back to have a communication between the sensor and the back end, or is it UDP? So we're sending out these datagrams, and much like streaming technology, we send out requests, we blast them out like a shotgun. We may not get an acknowledgment back, but it's not necessarily required. So there's that model, and then there's also the messaging model. Traditionally, HTTP is a request and response. I request a web page and make a GET, I get a response back, or I fill out a form on a web page and post a submission, and I get a response back from the server. But there's also the publish and subscribe method, which is shown in a couple of slides later. I'm going to show you the publish and subscribe method, but it's different. We'll show you how they're different. I wish that I could go through every one of these protocols with you, but because we're limited to time, we're going to dive into MQTT and CoAP next. The challenges that we see right now, because of the last two slides that I have shown you, you can imagine there is still sort of a Wild West feel out there with regards to IoT. We don't see a whole lot of standards that have fully emerged yet, and so the biggest problem is making everything talk and making everything where it's interoperable. We also have to consider that we have these new wireless protocols that we have to deal with. So how do we, in a pristine lab environment, simulate real-world conditions with regards to the network? Are we going to have to get physical sensors? If we're doing a performance test, are we going to have to get thousands of real sensors? Can we mimic those sensors? Are we just concerned with the calls, or do we care about the embedded system that might be inside of that sensor? So the goal is, how do we still see the end-to-end performance responses and be able to validate those responses? That's really where we're trying to help the market figure out how to get there. So usually the early adopters are going to be your telcos, your Verizons, your Sprints, because they're going to be rolling out these services to their cellular towers. If not already in some other countries in the U.S., it's coming very, very soon. And it's more of a firmware upgrade at the tower, so it's not like they have to send a lot of technicians out there to make this happen. So you will be hearing about this more as we move from, say, 4G LTE today on Verizon, say, to the 5G network, which is even going to be, up to, I've heard, gigabit speeds on your mobile devices. So think of it in this way. When we went from computers in the home or office to a mobile community where I'm taking this smaller version of a computer out into the field with me, it's a whole different network paradigm that happens. So now I not only have to worry about a connected network on a LAN that might be an Ethernet cable or Wi-Fi with higher speeds, but now I'm taking this mobile device and I'm way out in the country or rural area, and I'm connected to a very poor 3G network connection that has slowed my app down, and I have to think about that as a developer, how that user is going to be affected by that experience. So when I talk about recreating real world and the impact of the network, that can't be overstated. So let's talk about MQTT and CoAP, and we'll get into details. There's an open question about how MQTT is different from HTTP. I'm glad that you asked that question because we're going to answer that right now. MQTT was developed by a couple of guys from IBM who had to develop a solution to monitor an oil pipeline. So you can think of a sensor being put so many feet or yards in distance along a pipeline out in the middle of a desert somewhere. Those sensors are going to have to make calls or pings to let it know, let the application know that it's available, that section of pipeline is still there, it hasn't been cut, there's no problems. It's going to talk to some type of routing gateway. In this particular instance, it's called an MQTT gateway. That is going to receive those sensor readings, and it's going to send that data up into a satellite transmitted satellite phone for that purpose. It's going to get up into the cloud through that satellite connection, basically. So you can imagine the transmission issues out in the middle of a desert, and the payload has to be very, very small. So that's why it was developed. So it was developed for speed. It was developed for highly constrained network. It had to be fast, and it's not that new. It was back in the late 90s is when this thing was finalized, and it's continued to morph since then. When you see these new acronyms out there, there's a whole new list of them when you start diving into Internet of Things. Like IPv6, most people have probably heard about that because that affects the web as well. Running out of IP addresses, we need to move to a different version of IP and how many addresses we can have. But when you see 6 LOWPAN, that stands for IP version 6, low power, wireless, personal area network. And I know that's a mouthful, but really all it means is that these protocols were made for sensors and smaller amounts of data with smaller payloads. And they also need to be able to be secure as well, because these can be hacked just like any other protocol. So in MQTT's case, it uses an SSL TLS model of security. There's a separate version of MQTT that will run over the UDP, make UDP request, and it has a datagram model for security. So DTLS, if that makes sense. So I know we're getting into a lot of acronyms that a lot of people haven't dived down that deep before, but this is why understanding the OSI model as a performance engineer is very, very important. So how does that relate to HTTP? MQTT would use the publish and subscribe model. You could actually design it to use request response, but most of the time out of the box, people are going to use publish and subscribe, and that looks like this. You would have a broker. The MQTT broker is the gateway. A very popular one online is an open source broker called Mosquito, and you can have publishers who subscribe to a topic and subscribers who subscribe to the topic. So just think of a magazine. A magazine publishes information, and then a subscriber subscribes to the magazine to get the information. And so the broker holds all these topics with all of these things that have been published. Certain times they expire. You can have multiple publishers that connect to a topic, and you can have multiple subscribers that subscribe to that topic. So that's how the response and request are different. HTTP, we're going to talk about request response next, but that's how it's different from HTTP. It was designed for high volume, low bandwidth, low energy. It is event-oriented, which means it doesn't have to run all the time, which means it can save battery time. So when you see this polling word, that means we're avoiding battery drain there, and we only need to turn on when we need to transmit or receive information from a sensor perspective. Now let's talk a little bit about CoAP. CoAP could be thought of as like the cousin of HTTP and a little cousin. It's different from HTTP in that it goes over datagrams instead of TCP. It doesn't need an acknowledgement, but very much like HTTP, it has sort of a verb system. Like in HTTP, you have a get and you have a post. Have something very similar in CoAP for that. So there's 4 main verbs that you'll see, and we'll actually show that in our demo, how that actually works at a low level. But it's very much like HTTP, but it's basically taken out and stripped down the things that you wouldn't need for that. This is how this would look. Very similar to MQTT, and in these cases, the sensors themselves are the servers. What we traditionally think of as the servers that are sitting on the back end are actually the clients of those sensors. So there's a little bit of a paradigm that goes on there that you have to kind of switch your thinking. But you can have these very constrained environments going over sometimes miles, where there's a sensor on a light pole every so many, like a mile down the street. And eventually it communicates to, in this sense, we would call it a gateway, because that gateway's purpose in CoAP is to simply translate the CoAP data and convert it into an HTTP request that goes into the back end. It runs across the wire as binary, and that's how it kind of it speeds it up, because it turns it back into a 0 and 1, versus HTTP, which would be a clear text request that you can actually see the HTML, that comes through. So it's in text. HTTP version 2 is actually more like CoAP because it is also binary, one single binary stream and connection. It's asynchronous. It's very much like a RESTful call in an API call. And the verbs that we were talking about, get, post, push, and delete, very simple. It supports MIME types. It has header responses, like when you have an HTTP request that's good, it's a status 200. They have those type of requests that you can view, so you can know when something's not found or when there's something that's been overloaded, like the gateway. And we refer to a gateway in CoAP as a proxy because that's what it's doing, is translating that and converting all of those requests to traditional HTTP calls. Currently, there is a handful of tools that support both of these protocols. On the open source side, I love this name, Malaria. It is a way to test the mosquito, MQTT Broker. There's also some command line tools called MQTT Box, MQTT Spy. JMeter has plugins for both MQTT and CoAP. And on the commercial side, Neoload has supported it since 5.3. SmartBears toolset have supported it for, I think, over about 3 years. StormRunner began supporting it through an API that they have written where you can pretty much customize whatever call that you want. And beginning with LoadRunner and Performance Center version 12.55, they also began to support MQTT. And our company, TransactIQ or Endpoint IoT, we created the CoAP protocol and released it in cadence with Micro Focus when they released 12.55 last August. There's also something that I would like to mention. There are some plugins to the browser. One in particular, and you'll see this in the demo I'm about to play, is the Firefox add-in for CoAP called Copper. By downloading that, you can actually mimic the CoAP proxy in your browser so that you can do testing that way. And I'm going to show you a live website where after you see this demo, you can actually do your own CoAP and MQTT, just small tests on a live system so you can see what it's like to actually test this. Okay, so let's go ahead and start this demo. Give me just a second to switch over to this. And let's see if this works. I think that might be, this is it right here. Okay. So if you can, blow up your screen so that you can see this larger screen with me. This is the location on the Micro Focus site where you can download that protocol. It's the CoAP add-in. It is free. It supports version 12.55 and above. It's available now. I would recommend this Copper add-in from Firefox that allows you to actually see it yourself manually before you actually kind of run any test. And that's available for Firefox. Let's see what version. Yeah, version 55 is what we were using in this case. Okay, so this is the location for this site that I was referring to. It's called Testtheiot. And if you use the CoAP plugin Copper to go to testtheiot.com, and instead of using HTTP, use COAP in the front of it, you'll actually see and discover our testtheiot.com site, which supports both CoAP and MQTT testing. It's not made for large-scale load testing. It's just made for you to test out something instead of on some production site. So this has a library that is part of the default CoAP protocol for testing. Different, you might think of them as subdirectories. They would be like sensors, if you will, that are reporting back information. In this case, you can see we're reporting back a 5-digit number with this request as the payload, and we have these verbs that we can use to test get, post, put, and delete. And this is exactly what our CoAP protocol that fits inside of LoadRunner and VUGen actually does as well. So this is just a manual way for you to see it in your browser. And again, it's using the CoAP protocol to make the request on a different port, 5683, instead of traditional port 80. So if you have any firewalls that might block that, you might want to consider that. So let's look at that in VUGen. We've already downloaded and installed the CoAP protocol from the site, and we've installed it according to the directions. And when we launch a CoAP script, you'll see that it's not a record and replay. It is a template script, and it's actually because you don't need to record and replay. It's very simple, so you wouldn't need to record a site. So you can either code this from scratch with just opening up the script itself, or we've already got some hard-coded stuff in there that's commented out, and you can basically look through our code and replace any of the values and just tweak that code yourself. You'll see there's nothing in the init section and there's nothing in the end section. Everything is in the action section itself. So if you're familiar with the API inside of VUGen, you're going to recognize some of the names of these functions that we have, because we tried to mimic the web functions as close as possible. So what we're going to do right now is we're going to go through this script, and we're just going to uncomment out what we think we might use. We're just going to make a simple request here. First thing we're going to do is we're going to set some options. These are the same options you might set manually in VUGen from the GUI. We're doing it programmatically. We're setting up a variable called int property, and we're going to uncomment out the CoAP reg save param. So we're going to dynamically correlate and grab correlation data, very much how we would do a web reg save param in the web protocol. In this case, we want to capture this 5-digit number that's coming from this site, Testtheiot. So we're going to change the left boundary and right boundary to search through the response that we're getting back from the server, find that number that's between that left and right boundary, and save that off as a variable called test param. Now what we're doing is we're putting a start and an end transaction around a GET request called CoAP_request. That's the API call. So what we've got to do now is take out the static host name that we put in there and replace it with a parameter that matches our server name. So we could have just typed in testtheiot.com, but we just wanted to illustrate that if you had different environments, a test website, and then a real website, you could create a parameter just like you can with the web. That could be an IP address, and we're going to put in the testtheiot.com as the parameter value, rename the parameter, and now we're going to replace all of the instances where we have host name with this new parameter name. And we also want to change the end of the URL string from large to what we actually want to request. So we're going to change that to something called, it's a folder called test. And we have a hard-coded message ID that was part of our commented out code. We also want to replace that as a parameter too. And probably you're not going to want to use this same exact parameter type. We chose iteration number and made sure that it was 5 digits by making sure we had enough leading zeros so that we could just run this in VUGen as many times as we want. You're probably going to want to come up with a unique number or a correlated value or something of that nature that you're going to want to send. But you have to have a unique message ID. So we chose to turn that into a parameter, and we only need to replace that particular instance. And finally, what we're going to do is we're going to go down to the bottom of our script, and we're going to uncomment out this command called CoAP get int property. The CoAP get int property does something very similar to the web get int property, which is, in this case, an argument that looks at the payload size that comes back and makes sure that it's the right size. If we got a very small payload, it might mean that the payload was a failure. And if we want larger, more realistic sizes, then that's sort of like our verification check that this payload was good. So we want to turn on detailed logging. We want to play this in our script and make sure that we're actually getting what we expected. And as you can see in here, we can see everything that happened. We can see all of our parameter substitutions, and we have full log that would come back from that COAP proxy. So we can see that GET request that we chose is returning back 1 in the parameter called test param. We can see that the payload size is 58 bytes. So if I were running a real test, I would then validate that size and figure out if that was a pass or a fail. And then I could fail certain transactions based upon their size if I wanted to. So now let's go in and look at what MQTT looks like. So this is something that you would get standard with LoadRunner 12.55 or Performance Center 12.55. Very similar implementation. It's a template script with code that's already got some hard-coded stuff in there. You can comment out what you want to use. It has both the publisher and the subscriber logic in there. In this case, they do have stuff in the init in the end. So the init section, we're basically just going to comment out the command that connects to a specific MQTT broker. In this case, in Testtheiot.com, we've got the Mosquito broker running already. And because it's a different port than COAP, we can have both of these running on our site parallel. In the last step of our script, after it's done running all these action files over and over again, we're going to uncomment out the step to unsubscribe from the topic and disconnect from the MQTT broker. So we're just going to replace that hard-coded value. And then we're going to go into the action section and just take out the comments for what we actually want to do. And in this case, we're going to comment out the uncomment the publish. So we're going to publish to a specific topic with a specific payload. So we're going to publish to the topic called example topic, and our payload is going to be our iteration number and just some other, just small information. So this is a publisher just over and over as it runs this action file over and over in the controller. It's going to place this information in that folder or queue, if you will, which then subscribers are going to go and look for that information every time there's a change. So here we're actually putting some literal text, vuser, colon, and then we're going to change that to a parameter so that we change the number every time. And it's going to be based on the parameter type called the vuser ID. So if you were running this in the controller, whatever virtual user is in that number that's in your group, that's what's going to be transmitted in this payload. And also whatever iteration number it's on. If you've got this set to run 100 times in a row during your test, it will count that up. And so each payload is going to be unique for this publish command. And then what we would do is just simply test this out. We're going to make sure that we've got logging turned on for this. Also, I wanted to note that there is a monitor inside of the controller for MQTT. There is not a specific monitor for COAP. You could create your own custom ones with some function calls in VUGen. But MQTT was developed by R&D at Micro Focus. COAP was developed by us. But at this point, Micro Focus, it will take over the development of that protocol and extend it further in newer versions. So we've got our logging turned on. We can see that we're sending the information to that. We can run this and test this as many times as you want in VUGen. And at this point, I've run out of time. I can't get into the controller part, but there are some videos on our YouTube channel that will take you into the controller section and show you tests running. There's test results and analysis that you can also look at. We've got some blog articles out there that even go into more detail. And so I'm going to minimize my screen again, if I can figure out how to do that. And I had one other slide here that I wanted to show, which was based on what we've seen as far as best practices. Basically, it just means try to take a holistic approach and figure out how you're going to mimic not only the sensor call, but the gateway itself, get a great understanding of how that communication and those protocols work, and then start looking at things like network virtualization and service virtualization to fill in any gaps and that type of thing. So if there are any other questions, I'm available for to answer any of these. I see some that are on there, but I'm going to turn this back over to you, Chris, and let you take it from here. But thank you very much for your time.
Thanks, Scott. Thanks for that amazing presentation, kind of giving us a deep dive into IoT, a couple of the protocols, and I feel like this is just going to explode the landscape of everything that is really performance and functional for all of us out there in these software and other testing communities. I hope everybody got as much out of it as I did, and now I have to figure out how to present after having that mind full of stuff to go through. But thank you again, Scott. That's awesome.